Hi, my name is Zixiong Cao. I'm from ORS and I'm the host today. So welcome again to join us today. So this is a effort for providing more help to our users. And we know we have many videos already published, or we did some webinars before, uh, but still some people have problem to use it. And that's why we want to do it as a hands-on, and we want to solve the problem in real time. And the objective today is not to do a very a detailed tutorial for everything. I will show you how to use deep learning, particularly the segmentation wizard, to train a model for your image segmentation task. And the main point is to demonstrate the workflow. And I will try to help you to do the same thing on your computer and to make sure it works for you. And I'm sure you will have many questions. Some of questions are very advanced, I guess. And we welcome all questions, even we are not able to answer all questions. And my colleague, Mike Marsh, and you probably have seen or watched his videos on YouTube, or probably you joined his webinars before. And he's the right person to answer all questions, advanced questions. So we welcome questions today, even when we're not able to answer them. Even either I'm not able to answer or we don't have time to answer, but we will save all questions for the future, for the next advanced workshop. So please feel free to interrupt me and to ask questions anytime. And today is not a very formal webinar or very formal training. So we just do it like an open discussion.
Sounds good.
Okay, so you guys see my screen now, right?
Yes.
It is a dental CT, combing CBCT data. I use it for this demo. And you probably know already how to load it and to view the data set in 2D and 3D. And so I'm not going to talk too much about that. Just a little bit things like by default, it's not using the conventions that medical doctors are used to. So probably you need to flip your view to make it look nicer. And the goal for today is to, for example, we want to segment all the teeth. We can change the window levels to see the brightness and contrast change. Like the window level is here. For me, I always use the mouse, the right click of the mouse, plus the control key to make a quick change. So we want to segment all the teeth. And we often check the range, like by the range tool, it's like a thresholding. A threshold tool, we can check if the intensity of all the all the areas or structures have the same intensity. So this shows the color of the voxels or pixels having the same having the intensity in the range we set up here. So if we change the range, we'll see different colors, the colors on different voxels. And for sure, this data set, if we lower the threshold, the range, we may able to include more back teeth because they have lower intensity. But for the front teeth, because they have higher intensity, and we see the connection here, it will include all the connections, meaning the teeth will be connected. And we don't want this. So if we choose a higher intensity, a higher range, we are able to separate the teeth, but we are losing or missing the back teeth because the back teeth has a lower intensity. So it's not very easy to do the segmentation by the range, because this range is a kind of global threshold, so it applies to everywhere. So I'm going to use the deep learning to solve this question. And before that, because as I said, it's a hands-on, so I want to make sure you have something loaded on your computer, and I want to see them. I want to make sure you are ready to do the next step. Is that okay with you?
Mm-hmm.
So who is willing to be the first one to share your screen so I can stop sharing mine?
Okay. Can you see?
Yes. Yes, I see it very well. And let's see what's going on here. Okay.
So I've been, I don't know, I'll tell you a little bit about what this data set is. So we work with insects, specifically a fly called the tsetse fly. And we are looking at the structure of the reproductive tract at different points during development. And we're interested in trying to segment out some of the soft tissues that are in here. So I'll open up this. So we were hoping to be able to use deep learning to segment out some of these different tissues that we see here. And I've done this manually, actually, with an entire volume. But the issue that we have is that a lot of these, it's all soft tissue, so a lot of the gray values are kind of similar to each other.
Right. Can you show us what you did before, like manually?
Sure.
Yep.
Let me load that session
I think
up.
we can use them as the training set for the deep learning.
Okay. Okay. I'll turn on some of the segmentation that we've done already.
And you said you did it in the whole volume?
Yes.
Manually?
Yeah.
Wow.
It was a long effort.
Yes, that's exactly what we could do with deep learning.
So I don't know if you can see these yellow features. So these are milk gland, which is an organ which the fly uses to make milk. So this is a fly that gives birth to live offspring and generates milk during its reproductive cycle. So we were interested. So this is kind of tricky to pick out, but I went through sort of manually and pulled all this information out with the hope that we could use it to train the deep learning algorithm.
Right. So you did try with deep learning.
Well, so I've tried with last week. I tried to make an algorithm that would be able to pull these cells out here.
Yeah.
These are called owenocytes, but you can see they kind of stand out. You can see one here, one there, one there, one there. So I pulled out I originally wanted to use this volume, but I couldn't. I was able to pull out the individual slices, but I was not able to pull the associated ROIs with those slices.
Okay.
I wasn't able to figure out how to do that. Okay. So I ended up pulling a set of 5 slices. I painted the owenocytes, and then I used those. I made a multi-roy. I forget what the type of multi-roy. A dense multi-roy. So one of the categories was the owenocyte, and basically the other category was everything else that was not. Okay.
And when you said you pull out the 5 slices, did you use the marked slices?
Yes. Yeah. So I went to.
You have to
select the
select the original data set and switch to the image. Yeah, you're already in the image plane.
Yeah.
You did this because you watched a video showing this?
Yeah, I've been watching the tutorials on YouTube.
Yes, I see. It's quite an old video we did maybe 2 years or 1.5 years ago. And we don't recommend that anymore because we have a better solution.
Okay.
That's what I'm going to present today, the Segmentation Wizard. We never extract the marked slices anymore because that will that's not not the best way to do a deep learning.
Ah, all right.
Yeah, right.
Yeah, so I'll tell you what the outcome of that was. So I did the deep learning, I trained up a model, and it actually got up to like 95% accuracy.
Oh, that's pretty good.
But so it could make predictions on unmasked parts of the training set with no problem. But then when I loaded up another volume from which those slices had been drawn, it wasn't able to make any predictions at all.
I see. Yeah, so it worked well on the training data set, like the 5 slices training set, but it didn't work well for the other slices.
Right. From the original volume, it just painted everything as background and it didn't label any of the OINA sites.
Okay, I see. I think you are ready, and I show you because you have already made the manual segmentation, which can be used as the ground truth for training, for our next training step. So it's much easier for you to do. So I will continue. I think you are ready. So we'll switch to Noi, so we can make sure everyone is ready too.
Okay.
You see it now?
Yes.
Yep.
Okay. Okay, I think, yeah. Sorry, let me maximize this.
Oh, by the way, you are using the 2020.1 version.
Yeah, I wasn't sure about the version that we're using here. Is the one that I download and I got the license.
Your license will be okay for the new version. The new is 2020.2. So I don't know if you have downloaded it or not, but we can send you a link so you can download the 2020.2 and upgrade.
Okay.
Yeah. So the Segmentation Wizard did have some change from 2020.1 to 2020.2. So you are not able to reproduce everything I do today with the 0.1 version.
Okay, I can download it now if that's okay.
It's fine. You don't have to do it now. We can still using yours to try because your version also already has the segmentation wizard. It just some features are not available, but it's okay. Yeah.
So yeah, I'm working with CT scans, and I want to do segmentation to extract just the maxilla and it is individual. Yeah. And also I want to segmentate the nasal cavity. And I haven't worked really in any photo, just trying with the tutorials on YouTube, trying to just play around with the scans. And that's why I'm interested in learn about the deep learning and how to segment just the maxilla. Basically just bone and teeth as well. Okay.
So you particularly interested in the maxilla, not the mandible? And
yes, I mean, for this research that I'm conducting now, I'm just interested in the maxilla.
Okay. So you want to separate them, like we could do, what we could do is to segment probably all the bones in the beginning as a first step. We segment all the bones. In the second step, we could separate them, like to extract the maxilla as one region of interest.
Okay.
And for the cavity, you probably have the same questions here. The cavity may be segmented as one volume of interest first. Then you probably need to separate them to different cavities.
Yeah, I'm interested in the volume, but the problem is it's not real tissue there. It's just the virtual space of the nasal cavity, I guess.
I think it's okay. So we are able to get the cavity even it's a low intensity area. So I think we can try the deep learning now. So I'm going back to my screen. So I'm showing the workflow how to do this. Okay, to use the deep learning tools, we have a little bit of things to do, like an extra step to do, which is the preparation for the data set. It's a normalization. I don't need this anymore. If we check here the window levels, we see the histogram of all the intensities in this image set. And for me, it changes. It changes to on every data set. So for me, this data set has most of the intensity in the lower part. And because of the normalization step, the current Dragonfly can do is not optimized. We're going to optimize this procedure in the next version. But with the 2020 version, 2021, 2022, it's not optimized. So it works well for some dataset, but not well for other dataset. When you have a very narrow, a small area for the histogram, normally we should to normalize like this range to a full range, because currently this dataset has is a 16-bit unsigned integer. We can check here if we check the image properties. If we right-click the image properties, we see the properties of my dataset, and we can see my dataset is U-short, means unsigned 16-bit integer. So the range for this format is from 0 to 65,000, and we need to normalize this dataset to make it to be float. And to do that, we need another menu, which is in the modified transform. We have a convert, which is here. We need to use this tool to normalize my image set from like this range to a float format, which has a range of from 0 to 1. And for this, I need to check my real like intensity range, and I believe it's here from the intensity. From the intensity histogram, I find my real range is like from 0 to 10,000, not 65,000, because 65,000 range is from the data type, like 16-bit integer. And now I want to normalize from everything between 0 to 10,000 to a float in the range of 0 to 1. And for everything not in the range, we just put it like 0. And this step is particular to this dataset. Is not, we don't have a solution like this for everyone, for all the image set. So you need to look at your image set and to decide what to use here. If your image set is already float, then you are good. You don't need to do this. If your image set has a very good like spanned histogram, and probably you don't need to do this either. And from what I see in Jeffrey's computer just a moment ago, I saw, if I remember correctly, I saw the range you show here is like from -20 to something like 80.
Yeah, it's -26 to 52.
Right. In that case, we probably will do something.
Okay.
Yeah. So I'm going to finish mine first, and I'll go back to Jeffrey's computer. So this is what I do. So I filter my image set, and I only take the intensity from 0 to 10,000, and then I normalize them to float format and to from 0 to 1 range. After I do this, I keep this checked, so it will create a new image for me. After I apply it, I get a new image here. So now I'm switching back. I'm switching to the new data set I got, and you see now the range here is from 0 to 0.95, and you see the histogram is very well spreaded. And this is a critical step for my data set. As I said, it might not be necessary for your data set, but it's always good to check first. So can we go back to Jeffrey's computer?
Sure.
I'm stopping my sharing.
Okay. Yeah, this is one of the segmented tissues here.
Okay.
So should I go to the image plane?
Yes. You can go to the image plane, and you can right-click the image in the, no, not in the view, in the top right, the list, okay. The right panel, you're back to the, yeah. Right-click your image set and choose the image properties. Now we see, oh, it's already flowed.
Yes.
Okay,
yep.
Which is good. And oh, this is the, no, this is the converter. Just 1 second.
Sure.
Yes, it is flowed. And okay, if it's already flowed, it's good. You don't need to do the normalization anymore.
Okay.
So we check, can we stop sharing and we go to
sure.
noise computer?
Yeah.
Yeah, yours is quite similar to mine. You see the type is U-shot. Can you guys see my mouse? Because I'm not sharing, so yeah, of course you don't see mine. Yeah. So on the right panel now, in the physical size, you see the type is U-shot, right?
The total size here?
Yes. This is the type U-shot means it's the same.
I can give you control. Let me.
Oh yeah, I can request control. Okay. So you see this U-shot here means he has a 16-bit, like it also shows here, 16-bit format. So the data itself is from 0 to 65,000. But why he see negative numbers here? Because he has an offset here, minus 1024. This is from the DICOM, most likely it's from the DICOM format, because this information is used by the medical doctors to convert the CT number to HU number, because the HU number is for the air is minus 1,000. So they normally have an offset here, and for our purpose today, we don't need this because we are not going to see the HU number. We just need the real image intensity. So we should put this back to 0 and we apply. Then we see here the real range of all the intensity is from 0 to 4,000. But because it's a 16-bit integer format, so the range of the format is from 0 to 65,000. And as I said, current Dragonfly version doesn't optimize for this step, so it uses the 65,000 as a range. So when we normalize, if we don't normalize manually, it will normalize from 0 to 65,000 and convert it from 0 to 1. And that's not what we want. So we need to manually change this. So in the image converter, we just check this to be 0 and this to be 4,000, and this could be 0 too. And we do need this float, and we normalize this from 0 to 1, and we create a new image. And now we don't need the old image. We check off and we check the visibility of the new image. It looks the same, but it has a different intensity range now. If we check the window level, you see the range is from 0 to 1. So now this data is ready for deep learning.
Yep.
So is everyone with me? Do you have any questions?
No, I just have to go through these steps and all the individuals that I have. But yeah, I have to change the specifications. it's just in this case, right? Each, I mean, in this case, all the CT scans gonna have the same.
Yeah, because your scans normalized, but not normalized for our purposes. It's normalized to see the same HU number for the same tissue in different patients. So for Dragonfly deep learning, we need to normalize it again. So for your next patient scan, you need to do the same thing. If you want to train a new model in the other patient, or if you want to apply the model you trained on this patient to another patient, you need to do the same normalization.
Okay.
Yeah.
Thank you.
You're welcome. Okay, after the normalization, we can start the segmentation now. So I right-click the new dataset, and I start the segmentation wizard. Now we are in the wizard. So you see here we have 3 tabs. The main tab we're working on is the frames or the input. The input is for like the deep learning training input. So we are going to create frames. The frames is like the manual segmentation to be used as a ground truth for training. So we create a frame. When we create, it will show you the frame. If you lose it, you can always click to go back. And now you see a region here. This is the region we're going to use as a training set. And for the training set, it needs an input and an output. The input will be the image itself. So the intensities in this image, like all voxels intensities, will be used as the input for that model. And the output will be the labeling. That's what we are going to prepare now. By default, it has 2 classes. So normally we have one class as background. If you want, we can always use the first. It doesn't matter the order. You can always use one as background, the other as the signal. Like the signal now is the teeth we want to segment. So you don't have to rename, but it's always good to do it to remind yourself. So for me, what I want to do is, okay, I want to segment the teeth from this picture. Now I use the tool in the ROI painter. I can always use the brush with the range. We could paint without the range, but then we will paint everywhere. With the range turned on, we can paint only in the range. So it's easy for us to get the boundary information. Like if I check off the range, I can paint everywhere. This is not easy to get the edge of the region of interest we want. So we can always check the range. If the boundary is well defined by the range, we can do this. I just do a few to show you what how I prepared this. But as I said, yeah.
Sorry, how did you create the frame?
Oh, you just add.
Add, thank you.
Yeah. You just add. You will create the frame on the current slice. You see the slice number here.
Yeah.
If you move, we can move to another slice. Then we add again, and it always add the current size of your window, your view, image view. So if you like this, you add this size. If you zoom in, you will get a smaller area.
Okay, great. Thank you.
You're welcome.
Is it recommended to take more of the slice or to zoom in more closely on the features of interest?
Well, it's a good question. We should not zoom in too much because this size, the frame size, it is important for training. Mm-hmm. You don't have to include unnecessary region. You should focus on the region you want to like segment. Okay. For example, you don't want to do this too much. If you only care about the teeth, you don't have to do the whole slice. Mm-hmm. But you don't either to zoom too much to take only one slice because that will not give enough information for training.
Okay.
So I remove my other frames for now, and I go back to my first frame. So my job now is to segment this frame manually with what I want. Like for now, it's a teeth, and because everything else will be the background. So I mark the teeth area, and I will do a filling for everything else to be the background. So I could use, as I said, I could use the painter to paint everywhere I want, but I have to be very careful. It should not include anything which is not the teeth. So I should remove them. This is mistakes I should remove. And because each tooth has a different location, so the front teeth has higher intensity and the back teeth has low intensity. So I need to frequently change my range so I can get the correct boundary. If I made a mistake, I have to correct it now. Well, you can correct it later, but I show you, I did 4 of them, and sometimes we have the tool to make it faster. For example, we have a fill in the areas because we don't want the inside area to be not to be excluded from the teeth. We want them to be filled. So we do this filtering, and this will filter all the teeth inside. But it only fills when when it's a closed hole, it's a closed inside. And I can continue to finish all this. Then I will prepare. I will be ready to use this frame for deep learning. Before that, I would just check. I want you to start working now with your frames. So I want to check if you have any questions with your frames. Can we just do a quick screen sharing?
Sure. I had a question. Yeah. So to use previously generated or manually annotated features, how do you bring those in to this particular, into the wizard?
Yes, we do have a tool for that. I can show you now on your computer because you already have it.
Okay, I'll share.
Yeah, it will be very easy for you to use the wizard because you already have the manual segmentation.
Yeah. Okay, let's see here.
Yep. So I see you create a frame. You have 2 classes, which is good. And I do. Oh, do I need to request the control again?
Yeah, I tried doing that again.
Yep. I think I don't see the frame. Oh, maybe it's not in the right slice. Yeah. Okay. When it's not in the slice where the frame is created, you don't see the frame, but you can always click the frame to go back to that slice.
Okay.
And now we can do the fill from object.
Okay.
So we will fill the frame from an object, but now you have no object available, which means your manual segmentation is not in this session. So we need to exit now.
Okay, there we go.
Okay, so and what we are watching now?
Milkland is what we're interested in.
Is this the?
Oh,
okay. You are showing multiple ROIs.
Yeah, there are. I'm only really interested in one, which is Milkland.
Like this one?
Yeah, that one.
Okay, so let's start with only one. And Milkland, we could do. You have only one images data set, right?
Yes.
Okay, good. So we do the. Okay, we create a dense multi-ROI from the ROI. Then because we need a multi-ROI as the output, we can hide everything else now. Oh, what I'm doing. We can hide all this because we don't need to watch them all.
Okay.
And now this is the one we created.
Yep.
And this is a multi-ROI. It has the milk gland from, this is taken from your ROI. And it filled everything as background, but the background is like black, so you don't see it. If you want to see it, you can check the color and you will see what is the background.
Okay.
And this one could be used could be loaded in the wizard to fill the frames. So now we go back to the frame. Oh, where's the frame? Segmentation Wizard. We go back to Segmentation Wizard. And now we do fill from object. You see the option here. This is the multi-ROI we just created. And now it filled, like this is the background and this is the milk gland, but it doesn't.
It should be, just, I filled it in wrong.
Yep, that's okay. You just change the name.
Yeah.
So for you, it's very easy because you can create many frames and you fill the frames with the object. Then you are ready to train.
Okay.
You probably can change the size of the frame a little bit because this outside area you are not very interested because that will take more time for training and to applying. So you don't need to have them.
Okay.
Okay, you could do it again. Like I said, you can remove this.
Okay.
And you can zoom in. When you zoom in, it will make a smaller frame because it take only the current size. Then when you do the fill, now you have a smaller size frame.
Okay.
Right. And you can make more frames.
So how many frames do you suggest training with?
We could start with only one frame. If we do the manual preparation for the frames, I always start with one frame. Then I have a trained model. Then I do the prediction to other slices. Then I choose another one as a second frame. Then I then I train train again. But for you, since you already have the training data set, that's a manual segmentation. You could create like 3 or 5 frames. Normally 5 is good for most of the tasks. 5 is good.
Okay.
But you need to know more frames, meaning more time, means more training time. So if you want to see it quickly, you just use less frames, like 3 frames. And if the trained model is good and you want to keep improving that, you can add more frames.
Okay, gotcha.
So let me give you access.
Okay, you did it quickly. Oh, I have the access now. Okay, yeah, I see you did it very quickly, and which is very nice. And you could, if you want, for example, if you want to segment the inside, like the pore area, the root canal, if you want to do that, you need add a new class. You could do that. I think you have good picture. It's good to do that. So you could add a new class to do that. And you if you don't want an extra class for the inside part, you don't have to do it. We just start from the easy part, so we don't do it now. But we feel we could, in that case, you could manually paint them like this. Or if you don't want, if you want to segment only the teeth, I think it's fine too. We just do a little bit of correction, then we can start. I do this quickly for you, and then we start training immediately. Okay.
Okay.
All right. So you see, we have done only one frame with. If I want segment only the teeth tissue, and I can set the other class as the background, and I right-click the other class, and I say add all unlabeled voxels to the class.
Oh, okay.
So now I have filled my frame manually. Like Jeffrey filled from a previous saved object, and now we filled the frame manually with the two classes, and now we're ready to train. We need to add a model. So now there's no model here. We need to add a model, and we normally start from with the UNet, and we check the level to be 4. Like there are many parameters in the training or in the model architecture or model types, and in the training set, in the training parameters too. There are many things we can play with. That's some like advanced topic we can do later, but not today. So we just keep it simple. We only change the level to be 4, then we generate the UNet model, and we keep all the training set to be default. In your version, you are not able to change the training parameters. In the 2020.2 version, you are allowed to change the training parameters. But now it's okay. We keep everything to be default, and we do train now. Oh, oh yeah, perfect. Oh, okay, it's being trained now. So and it's very quick, and it has been. In the new version, we see a curve of the loss function, but in your version, we just see the number. So you have done 20 epochs, and I think we can stop now to see if we have anything done. When you stop, it saves. Oh, it doesn't stop. Oh, it stopped. Okay, when you stop, it saved everything in the model here in the wizard, and it will. Oh, I see. It's training some automatic generated models, not the model we created manually before it, because the program will create some models for you, like suggested models. Some of them are useful, some of them are not very useful. So personally, I don't use them every time. I just skip them. But because I didn't see the skip message, so it's training now. And we have a strategy window too. Well, so now it trained 5 models with the only 1 frame, and it shows the 3 models on the top with the best scores. Like you see, the first one is by random forest. It's not deep learning. And the second one is also not deep learning. And the third one is deep learning. The third one is the one we created. And all the others were created by the application, like suggested models. And we could see the result now. And in the here in the button, we see 3 image views. They are the predictions of the model applied to the same frame. Here is a frame we use for training, so it's not very convincing. So we probably can change it to another slice, and this slice has not been used for training, and we create a new frame here, and we do a predict. Yeah, looks most of the prediction are.
It's taking some bomb, but it's kind of accurate.
Yeah, it get the most part of the teeth because you have only 1 frame and you didn't train many times, many epochs. So of course it's not a perfect model yet. You see here that there's a lot of mistakes, but still it worked for some teeth. Like here, it was pretty good. And what we do now is to use the predictions here, and you can like use this arrow, this button. You can move the prediction to be your training frame. Then you could work on this because it's much easier to have something like than to working from the scratch. Now, what do you need to do just to make corrections? So if I choose teeth, I could make the corrections very fast, because these are mistakes I want to remove from my, yeah, you just need to remove the mistakes. If you don't want to see this, you just check it off. So you do some manual correction. So those are errors, we just move them. So if you have more accurate training frames, for sure you will get a more accurate model. And after the correction, maybe you want to add some more. If it's not identified, you can add some more. And for this one, maybe you don't want this to be recognized as teeth. You remove them. Then you do this again. You have to add all unlabeled voxels to the background. You should not have any pixels to be unlabeled like this. You can.
Okay.
Yeah. There's some tricks here. You see the background class here. You could drag your class. If it's a background, you can drag this class here. You don't have to, but if you do this, it will use always this as background. So what it means, when you remove from other class, the removed voxels or pixels will be automatically added to this background. So you don't need to do it like 2 times, 2 steps. If you remove, for example, if I remove this from my teeth, it's already being added to the background. Now you have 2 frames, and you can use the 2 frames to retrain the model. We don't need all the models to be trained, so I remove the models we don't use today. We'll make it faster. Like how to choose the best model and how to train it to the best performance, that's some advanced topics too. We could talk about that next time. But today we are only go through the workflow, so we don't say too much about that. We keep only the unit level 4 that we created, then we do the train again. Oh, here there are some mistakes I didn't correct. So if you see the loss function is getting smaller and smaller, and in this iteration, like the second training, you supposed to have lower loss function, and loss function is calculated for both the training dataset and the validation dataset, because we split the training data to be 2 groups, like 80% as training and 20 as the validation. So you see the loss function, both of them. So we can go back to Jeffrey to see if you have made enough frames, so we can train your data set now.
Yeah, so I actually started the training. Let me share.
Let me stop to share.
It's going fairly slowly. I made 3 frames.
Okay. 3 frames, and because the size of the frame also matters. It looks like you have a big size the frames in terms of how many pixels in the frame.
Okay, so that's what's.
Yep.
Yeah, because
it looks like big.
Should I go back and choose smaller frames and restart maybe?
If you want to see some result quickly, yes.
Okay.
Because I want to make sure you get something today.
Yeah. Let me go back and reset the.
Yep.
Okay. So I'll just remove these frames.
Can you try again to resize the frames?
Sure.
Yeah, oh, that's okay. You already did it, so try it next time. Because I see the problem sometimes too.
It's something like this, maybe.
Mm-hmm.
Okay. Yeah. So like, if I try to grab and drag, I can't grab the handles.
Okay. Yeah, normally it should be okay. For me, sometimes yes, sometimes no. I never got the when.
Okay.
I
Should I
think it's
just
good.
use one frame for now?
Yes, but can we double check is this correct? Like, can I take the control and
Oh yeah, sure.
yeah, just 1 second, because I see somewhere, I'm not sure if it's correct. Like here we can change the opacity of the labeling so we can see the more opaque.
Mm-hmm.
Because you know here,
Mm-hmm.
I don't know why is this what you want? Like you covered this, you don't separate them because there's a kind of a small crack here. You don't.
Yeah, I think that's kind of a sloppiness on my part. So
Okay.
it could probably be adjusted to eliminate the space between those tubes.
Okay. Yeah, in that case, I guess you probably need to correct this. If you want a more accurate model, you probably need to correct this.
Okay.
But you don't have to do it now. Even without correction, we should be able to find something.
Get something.
Yeah, not
Okay.
perfect, but it should be working.
Right.
Here also, you see what I mean, huh?
Yeah. Yep. I think I was doing the whole thing by hand, so I got tired at some point. And
yeah, I understand. That's why
sloppy.
we need the segmentation wizard. We only work with a few frames, not the whole data set.
Yeah.
Too much. Okay, I think we still can work from here.
Okay.
Just to make sure it trained a model that do some predictions.
Okay.
And we can move a little bit and create. Can you do that? Create another frame and fill the frame. Yes.
Do you want a third frame?
Let's start with 2.
Okay.
Yep. Now we could go to the models tab. The right
models.
Yeah, yep. Models. Oh, yeah. There are many. As I said, there are many models automatically generated or suggested by the application, by the wizard itself. So we don't need all of them. We keep the first one and we delete everything, all the others.
Okay. Okay.
Yep, we can. I think we are ready to train. Yeah.
Okay.
So you see in this version 2020.2, we see a curve, like how the loss function is changing. Is normally it's decreasing after every epoch. Now every epoch, now it's taking about 1 minute for one epoch. We expect to see something after 10 epochs. So we let it go about like 10 minutes.
Okay.
Just
if you want to switch to
let's just wait until 2 epochs finished.
Okay. So the numbers that I'm seeing, is that like the prediction accuracy? It's like roughly 50%.
It's not exactly the accuracy of the prediction. What do you see the number here? I think it's loss function. The accuracy is not shown here. I think it could shown if you see my mouse, if you check here, the dice coefficient, this is more about the accuracy of the prediction.
Okay.
So now we see 2 curves. One is increasing, is the loss function for training data set. And the purple one is for like the validation. So that's why it said val for validation loss function. It could go up and down for a while, and if everything goes well, it will decrease to and converge to some bottom line and to be flat for a while. Then we can stop there.
Okay.
But it may change all the time.
Yeah, the previous model that I ran, that worked well with the training data. It didn't start to actually shift until about 100 epochs in, and then I started to see improvement. I don't know if that's unusual or normal, or
if it takes 100 epochs to see the decrease, that sounds abnormal to me, because I never had that. I have some cases that it never worked. It never got a good training model to predict something. In that case, it never decreased even after 100 epochs.
I can show you the graph if you're interested. Just to,
yes, I am.
I saved it. Let me find it here. Are you seeing the screen or
yes.
just okay? Let's see.
Oh. Okay.
Zoom in a little bit.
Yeah, I see it.
Okay.
A lot of ups and downs and
a lot of jumping around.
Yeah. But the trend is still decreasing.
Yeah. It's like once it hit a certain threshold, all of a sudden it started to drop.
Okay. Personally, I didn't see this happening to me, but I think it's a good case. I think our developers or Mike Marsh, because he has more experience on this. I think they probably have some explanation, and maybe they have seen this before. I will show them, because with the recorded video now, I will show them and discuss with them.
Okay, I did make a second model, and I didn't see nearly the amount of variability that I did with this one. But I still had the same outcome where it was able to make predictions on the training set on the unmasked areas, fine. But then when I opened up the other data set from which those slices came from to apply it more generally, it didn't identify anything. So I don't know if it's overtrained, you know what I mean? If it's recognizing training set specific features somehow.
That's the overfitting issue people are talking about. But it should not be totally bad. I mean, if it doesn't predict anything, it doesn't sound good to me either. If even with overfitting, it should do some prediction. Maybe not as perfect as the training set, but it should do something.
Yeah, I was expecting to see something, but it seemed like it was just all everything was background, which seemed strange to me. It wasn't even that it was inaccurate, it just wasn't doing anything.
Right. I think there might be something wrong, but not other than the overfitting issue, might be some other issues.
Yeah, I didn't use the segmentation wizard, so I was following the protocols on the that I think it was Mike's YouTube video from this summer on deep learning that I used. So maybe it's different now.
Yeah. Mike did the first deep learning video, I think last year, more than 1 year ago, using the market slices as you did, to extract a few slices from the entire volume and to do, because that worked well if you do 2D UNet. If it's 2D UNet model, it doesn't take other slices, the slices other than the one you used for segmentation, for manual segmentation. So that's probably the same. But we with Segmentation Wizard or with the new version of Dragonfly, we can do multi-slice UNet. it takes not only the current slice as the input,
Mm-hmm.
it could take more slices, like adjacent slices, like every every slice or every other slice. It take I think up to 11 slices.
Mm.
That
I
would
saw
be.
there was a 3D unit. I don't know if that's.
Yes, we actually have two versions of 3D unit. One is what I just said, multi-slice. We call it a 2 and 2.5D, but it shows as 3D when you choose in Segmentation Wizard or in the deep learning tools. When you create a unit, you do see 2D or 3D. But with multi-slice, it's not truly 3D, but we do have 3D unit. That's another option. The 3D unit will take like a cube, like 32 by 32 by 32 cube. It will do a 3D convolutional kernel on it to extract the 3D features. Ideally, it should work better for most of the images, but it takes so long time. It's very slow. If you don't have a superpower GPU, it will be super slow. So it's not very practical to begin with. Right?
Yeah.
I see now your loss function does not decrease very well, not converging very well, but it's still normal. In the first, as you said, it used to be more than 100 epochs to get a decrease, and now it's only 10 epochs.
Yeah. To get it to do that, I had to shut off the early stopping function.
Yes, otherwise it will stop because it doesn't improve. If it doesn't improve in 10 epochs, it will shut off.
Yeah.
Yes.
It looks like it's about to stop.
Now, yes. So, let me think. That's a few possibilities. One is your labeled like the milk gland is quite small compared to the whole picture, the whole image. It's quite small, so it's not the very easy. It's not the easiest one to train, and because some of the mistakes in the labeling in the frame. Okay, yes, it doesn't get anything. Do you mind if I control the computer to some testing?
Okay. Not at all.
All right, so let's do some quick test to see why it doesn't give you anything. Because always I expect to see something first, then I see how to improve it. If I don't see anything, that's not very nice. So I try to make an even smaller frame to make it faster.
Okay.
And I feel again. And I check if it doesn't mean anything. But this milk gland are not very not very easy to detect, actually.
It's a difficult tissue. I do have some other ones that might be easier. I could refine this more.
Yeah, I prefer to start with something easier because this visually it doesn't look very different from the other tissues.
Yeah, it's tricky.
Right.
Part of it is I have to follow it over multiple slices to, you know what I mean, for continuity's sake, because they're tubes. So
yes, I think that's a very good point for why we have multi-slice models.
Yeah.
Yeah, and currently we are training a single slice model because the multi-slice will take more time. I don't want to use it for demo for now. So,
we need to take one of the other ROIs and make a multi-ROI out of it, I think.
Yes. We could exit this. Every time we exit the wizard, it will save everything we have done. So like the model trained or the frames we created, it saves everything in this object. So if you want to save your work with wizard, you just save this object.
Okay.
Yeah. So
here, let me see if there's one that's a little easier to. Yeah, so maybe, so this one, the I'm going to shut off this other.
Yep. This one is very good to start with.
Yeah, so these are tubes. They do end up blending into the structure here.
Mm-hmm.
Let's see. Yeah, I guess we can try this, or let me see if the oocytes might be better. So this is a multi-ROI already that's got different, I think that one might be confusing.
We could try multi-ROI with multiple labeling to multi-classes.
Let's try this one, the spermatheca, or the spermatophore. Yeah, because I think this one's a little more consistent.
Okay.
Okay, let's try this.
Yep. So you create a dense multi-ROI from this.
Okay.
Yeah. You probably need to rename it, so in the wizard we know what it is.
Okay, and then we go up to the wizard.
Mm-hmm.
I'm just gonna.
Yep. You create a new wizard, but it's okay.
Okay.
We no. It's totally fine. I just remind you. We are working on another wizard. If you want to try multiple times, it's good to start with different wizard, because if you delete it, you probably won't be able to recover it later.
Okay. All right. Let's see.
Yeah, this is perfect. Oh, you don't see the other multi-ROI.
Let me see if this is. No, that's the old
you
one.
don't. That's weird. You are you sure you have only one data set? Because the geometry of the data set is important for this.
Let me see. There's this data set. I can shut these off.
It looks like you have only one.
I'm just going to reduce the amount of stuff that's here. Should I get rid of this other wizard?
You could. Yeah, we don't need it today, so you can always start later.
I'm going to shut off everything that we're not working with.
You could multi-select if you want.
Oh, okay.
Yeah. Yeah. Okay. Can you wait a minute?
Sure.
Okay.
I'll let you take control.
Okay. I want to, so I cancel this because, as I said, the geometry is important. The geometry, we can take information from the basic information from here. So we need quickly check. You see, it doesn't have the same geometry. You see, the data has this size, and the multi-ROI has this size, which means sometime you created a ROI from, maybe you cropped the data set, or maybe you have two data set with different size. So you at one point you create a ROI from the other data set, and they don't have the same geometry. That's why you couldn't see it in the wizard.
I see.
To fix it, we can resample geometry.
Okay.
So what I'm doing now is to resample the geometry of the multi-ROI to make it to be the same as the dataset.
Okay.
I didn't expect it take such a long time to resample. Okay, so Noi, can you or do you want to share the screen now?
Yeah.
Yes.
This is the second one.
Yes. So the lower part is the prediction. Yeah, the upper part is the training set that we made. And
let me give you the control.
Okay. So we did 2 frames. And we got the trained model now. So if I want to improve it again, so it can even in this slices, because when we see the previous frames we did, we don't see much bones around the teeth. We see a little bit here, but not much. And this one has almost no cortical bones here. So if we want, the model can do a better job even on this kind of slices. We could add one more frame.
Okay.
So we can do the prediction again and see how it works on this slice. You see, most of the teeth part are okay, but for the bone part, you don't want this. You don't want this to be labeled as the teeth. So you should, what do you do? What you can do is to do this and to correct this, to remove the bones from the teeth. Or you can add a new class if you want to separate, if you want to create both at the same time, both the teeth and the bones at the same time. At the same time, as I said before, you can add a new class. But then if you add a class, this model will not be valid anymore. It will be removed or reset. So you will start from the scratch, from the beginning.
Okay. So in this case, I use this and I start to remove manually all the bone again.
Yes, for the bones, you need to. Yes, if you want to separate the teeth and the bones from the same at the same time by one model, you need to have some bones and do the bone segmentation manually. Like you need to have a frame like this, and you need one more class. Yeah, this will be a warning.
Okay.
Yeah, it doesn't matter. We just agree. So this will be a bone. Like then you need to mark to label all the bone tissues to this class. Right. I could give you some tip to make it faster when you do the correction. So let's do the. Oh yeah, sorry, I already deleted the model, so we have nothing now. Okay, so now it's time to retrain. We can do it here. You see now, this should be the bone. I can double.
Oh, you want me to change the name?
No. It's fine. Oh, you could change the name, but it's okay. It's not my point now. What I mean is, when you paint the bone, you could paint like this, right? Because maybe these are all bones. When you mark the bones, you add it to the new class, the bone class, and then you remove it from the current class. So now you are removing it from the background. But if you want, there's always some tip to make your work easier. Like for example, if I paint here for the bone, I don't want to change my teeth. But what I'm doing now, if I go my painter, if my painter go to the bone, it will change the bone it will change the teeth to bone, right?
Yeah.
If I don't want that to happen, I could do this. Like I select the bone and select the background altogether. In this case, my painter only paint on these 2 classes, so it doesn't take effect to like now I cannot paint here, but I can paint here. So it's like to lock the other class and change only your selected class. If you use the control key, you just add the pixels to the first class, the A class A. If you use the shift key, it will do the opposite. So it will remove from your class A and put it to class B.
Okay.
Yeah. So sometimes it's very helpful to speed up your painting. For example, here if I want only change the paint here from the teeth to bone, I can double select this too, and now I press shift key. I see the brush, the brush color changed to blue. So which means what I'm picking is for blue. So I change everything to blue, and then without affect the other class.
Okay. So that's if you select, you shift select both of those.
Yep.
Okay.
So now when I do this myself, I don't care which two classes I selected. I mean the order which is A and which is B, because I can always change or switch by the keys. If I use control key or use the shift key, I see the brush color changes, so I know which one I'm painting.
Okay.
Okay.
How many classes can a deep learning model handle?
Well, I think there's no limit for that. I saw a person did like 30 classes, but it will. I never done that. The most I did is 5 classes.
Okay.
Yeah, but I don't know we have any limit for that.
So we could do like a detailed breakdown of like 5 slices and then use those for training.
Yes.
Of every organ that's in a particular slice, or
yes.
Okay.
I think what you did is very feasible for deep learning, like 5 classes or 6 classes. What you need is very good training frames, like very well segmented, prepared, very accurate training frames.
Okay. The resampling did work, and I've selected 3 slices and annotated them and everything. So
okay, that's good. So we can switch back to you.
Stop sharing.
So now we have yes, you have 1 frame. Let's control again. And you created 1 frame and you filled the frame. Oh, you created 3 frames. Good.
yeah.
Let me check 3 frames. Okay, I think they are very good. Then we can create this is the same model we did before. Oh, you created this model, right?
Yeah, I just created it.
Okay, perfect. So we everything okay. We do so you see in this version we have this option. In the 2020.1 we don't have this. This is for change the parameters for training, like the patch size.
Okay.
For your data, I suggest to use a larger patch size.
Okay.
And for this is early stopping, you know this, you did this before, and everything else is fine, I think. So we just change the patch size and everything is by default. Then we do the training. This is the suggestion. This is we call it strategy, and this is suggested. Not really suggested. This is available models. Like the wizard will see the image and the training frames and determine what models are available. But for now, we don't need any of them. I just remove them and then I do continue. And that strategy will be improved again in the new version 2020.3. So for now, you just need to skip.
Okay. Yeah, it's moving much faster now.
Yep, it's much smaller, and I use the bigger patch size, and that should be important for your data set.
Yeah. So the bigger the object, the bigger the patch size. Is that
the bigger the feature? Like if the previous one you want to do the milk gland, the feature itself is quite small, so you should use like the default patch size, which is 32. But this one, the feature is much bigger. So if you use 32 patch, so for many patches, it has only one class.
Okay.
And that will not be very useful for training. We prefer like in one patch, you have multiple slices. Multiple classes. And in Wizard, we save, as I said, when we exit the wizard saves everything in the wizard object. Okay. But if you want to use the model trained, if the model trained in wizard is good for you, you want to use the model for the whole volume, you have to save the model first, so you can use it in the main context.
Okay.
But in the future version, we will make it available in the wizard to do the full segmentation for the whole volume. And now in this version, you still need to save the save key. The button is here. It's not available now when it's training, but after training, you can save it to the main context.
Okay. It looks like it's beginning to decrease now.
Yeah, it's still a little bit jumping, but I think it's getting there. It's getting lower.
Do you think it's because of it's such a tight sort of the change in intensity is so low that it's having some?
Yeah, I think that could be a very important issue. That's why I'm worried about the normalization, because your data is a bit special. You have negative values. I need to ask our developers if the negative values has any impact. What I know is we will always normalize the total range to from 0 to 1. No, it
yes,
still doesn't give anything. Well, this is something I didn't expect for sure. And I will confirm with our developer about the normalization, about the range. Is that possible to share like 3 slices of these images to me?
I can give you the entire data set if you'd like.
Oh, sure.
It's online and it's available for download.
Okay. So it's a public data set.
Yes.
Yeah, I'll be very interested in trying this on my computer, and maybe there's something we should learn from.
Yeah, they were. It was imported from TIFFs that were scanned at the advanced light source.
Yeah.
Yes. Yeah, here it is.
Okay, cool.
Should I just put it in the chat, in the Zoom chat?
Yeah, you could do that. Yeah, put it in the chat. I will save it.
Okay. Yeah, because if you have any insights as to maybe there's something strange about this data set that is throwing off the...
Right, I will test it on my computer to train a few models to see which one might work. And if not, I will talk with our developers. Okay, before we stop or before we finish, do you have any further questions?
Yeah, I do have a question. Okay, I did another example. And how I put the class as a background when you paint all in green. Can you remind me that, please?
You drag. You already put this as a background.
Yeah, but I don't see it in green. How I do that?
Yeah, because you mean this one? You right click. I don't have the control. You right click on the green class, then you add all. You can always add all unlabeled voxels to any class, right? You can do this. You have this menu to all the classes, but you only use this for your background class.
Okay.
And if your background class is already here, but it's not necessary to put it here. But if you put it here, as I said, when you remove something from the other class, then they will be added to this class automatically.
Okay. Yeah. Thank you.
You're welcome. I will talk to you later. We can schedule some other meetings about the nozzle cavities and some other tissues of your interest, so we can help you further.
Thank you.
You're welcome.
I'll keep playing with it and see if I can make any progress on ours.
Okay. Yeah, keep trying with the wizard. I think it's because we haven't tried out any other options like the multi-slice option. Multi-slice unit is a very good one to use. The 3D unit is, as I said, it's very slow. It's not the best one to start with, but multi-slice is very good.
Okay, I'll try it.
All right.
Okay.
All right.
Okay.
Great.
So thank you guys for coming.
Thank you very much.
Thank you.
You're welcome. Have a good day then.
You too.
Bye.
Bye-bye.
Bye.